We started the semester talking about background stuff, and then we started talking about how do we know what we know and how do we figure things out, and then we transitioned into finally starting to do some actual astronomy, and that is we talked about the formation of the solar system. Now, your book, after chapters 7 and 8, the formation of the solar system, and then 8 also talks a little bit about extrasolar planets, moves into chapter 9, which is studying the Earth. This is how it's been done historically for a long time. When I first started teaching astronomy, we follow this same basic order. Most textbooks still follow this order, and it talks about the Earth because we know the Earth at best of all the planets. It's the one we live on. We can take samples very, very easily on it. And the next thing that you talk about is normally the moon, because it's the next closest thing, and we can see it easily with the naked eye. Then you start going through the solar system in order: Mercury, Venus, Mars, Jupiter, Saturn. When I first started teaching astronomy, that's all that we really knew, and we had spacecraft on the way to Uranus. And then, remember, when I was teaching the lectures, I was teaching labs at first, and then I was teaching the lectures, and first lecture, we had a spacecraft on the way to Neptune. At the end of each semester, there was just a generic chapter at the end called miscellaneous stuff. The miscellaneous stuff was meteorites, asteroids, comets, and Pluto, because we really knew very little about any of those objects. And so most textbooks have kept the same traditional order. Now, I've actually, for a number of years now, have deviated from this order. After I talk about the formation of the solar system, I like to jump to the minor objects of the solar system: asteroids, comets, and meteorites, and things like that. Now, the reason I do that is that when I first started teaching astronomy, we only knew of a couple hundred asteroids or something like that, and maybe 100 or so comets. We now know a whole lot more about these objects. We had never seen an asteroid or comet up close. Now we've had spacecraft that visited and landed on asteroids and comets. We've got samples that we've collected. We know a whole lot more now than we did at that time. We also understand a lot more about how planetary systems form. And so what we find is that the small objects form first. So these asteroids and comets are by and large leftovers from the formation of the solar system. Really understanding the solar system and how it gets the way that it is necessitates understanding asteroids and comets. And so what I have done for the last about 15 years or so is I've skipped, after the formation of planets, I've skipped straight to the chapter on asteroids and meteorites and comets, because we now know so much about them that we can actually say some interesting things. And so that's my strategy here. So we're going to skip all the way now to chapter 15. I promise we'll get back to the other chapters. So, kind of filling in some things here, because as you've noticed, I've really liked the history of astronomy, not just the factual science, but the history. How do we learn all this stuff? And so I like to fill in some of this background stuff. And so go all the way back to Giuseppe Piazzi, when he discovers the object Ceres. Now, he actually kind of discovered this as a matter of fact. He was looking for other stuff, and he discovered Ceres. And so that began the study of these little small objects that are out there. And so here we have traditional for astronomy classes, you need to have a picture of a star field and then just mark this dot on there. So here we have it. And so that dot right there moved from there down to there between these two photographs that were taken on different days. And so that moving dot right there is Ceres, the very first of the asteroids. So in keeping with my idea that I enjoy talking about the history of astronomy, I want to bring up something that was kind of the in thing at the time that Ceres was first discovered. And that was something that we call the Titius-Bode law. Now, the idea was originally formulated by Johann Titius, and he really didn't get a lot of credit for it. But 6 years after he came up with the idea, Johann Bode, who was a famous astronomer at the time, made this sort of thing famous. And so most books refer to it as Bode's law, and Titius normally doesn't get credit for it. I'm just going to go ahead and give Titius credit for Bode's law. Okay, so this is the Titius-Bode law. In fact, a lot of books really don't even mention this at all anymore, but it played a very big part in the discovery of it played a very big part in the discovery of asteroids. Your book kind of just barely mentions Bode a little bit on page 438 in terms of the search for missing planets. And the reason for this is the idea that Titius had was he took a sequence of numbers, 0, 3, 6, 12, 24, and so forth. Notice each one is doubling the one before, the oddities, that first one right there. Then what he does is he adds 4 to every one of those, and then he divides by 10 to get that sequence of numbers right there. Now, the interesting thing is that sequence of numbers almost matches the actual semi-major axes of those planets. Those are the only planets that were known at the time. In fact, at the time that he first came up with it, they'd only just discovered Uranus, and it seemed to match all this. And so they got to think about this, and they thought, well, wait a minute, there's a missing thing there. So they got to looking for this missing planet. Now, reality is that, you know, if you already know a set of numbers, if you try hard enough, you can find some sequence that will actually fit that set. So this is not such a big deal. Okay, any random set of numbers, you can find a sequence that'll fit it. So in all likelihood, that's what's happening here, not that it's really a mathematical relationship, not like Kepler's laws or Newton's laws. But they didn't know that at the time. But the idea was there might be a missing planet between Mars and Jupiter. And so Baron von Zach, another famous astronomer, enlisted several other astronomers, mostly German astronomers, Ende, Gildemeister, Schroeder, Olbers, and Harding. Olbers and Harding being very famous for other sort of things as well. And they started searching the sky looking for the missing planet. Well, it didn't take them very long to realize the entire planet, the entire sky is way too big. So they call themselves the Celestial Police. There it is in German, the Celestial Police. And so they're searching the sky looking for this missing planet. And they realize it's too many of them, so they enlist the help of some others. Okay, Bode is on the list here, as is Messier and Michane, who helped Messier. William Herschel's on the list. So a variety of these people are actually famous in other sort of ways. Now, the two at the end down here, Oriani and Piazzi, were these two Italian astronomers that, for various reasons, mostly political, they were not invited originally. Okay, but Piazzi was searching for something else and discovers Ceres. So what happened was Baron von Zach immediately recruits him to be part of the Celestial Police, and as soon as Piazzi agrees, then they release an announcement, like a press report, saying the Celestial Police have now found the missing planet they were after. And so but Piazzi found it, and other people in that celestial police kept looking through the sky, and interestingly enough, Olbers comes along and finds another one of these things, Pallas, and then Harding finds Juno, and then Olbers again, finds another one, Vesta, and so you ended up with several missing planets, not just the one they were expecting to find. Now, they knew the objects they found between Mars and Jupiter, because what they could do is they could measure the synodic period. Okay, now you know the synodic period, you find the synodic period by finding how long it is from opposition to opposition. After you have the synodic period, you can calculate the orbital period. Remember, we talked about the equations, how to do that. And then using Kepler's laws, after you have the orbital period, you have A, the semi-major axis. That was bigger than Mars' semi-major axis, smaller than Jupiter's semi-major axis. So these objects were all in that window, that gap between the two worlds they were looking for. Now, reality is, we now know there was never a planet there. At one point they thought maybe the planet broke up because it broke into all these little smaller pieces. No, that's not the case at all. Okay. Now, what they finally decided, though, was these were on the list of planets. The solar system: Mercury, Venus, Earth, Mars, Ceres, Pallas, Juno, Vesta, Jupiter, Saturn, Uranus. Okay, then they discovered Neptune about this time. Okay, and so they realized, though, that these things were all way too small to count as planets. So they eventually took them off the list. And the layman's term for what they became is asteroid. Professional astronomers never really got around to naming what these things were, but asteroid became like small star, so became the layman's term. So there were too many of them. They were dropped off the list because they started finding more and more and more of them. We now realize they are leftovers from when Jupiter moved inward, so they never were planets. They never got a chance to make themselves into planets. Some of them may have been planetesimals that ran into each other and blew themselves apart into smaller objects. The official term that astronomers eventually decided on for these kind of objects is minor planet. Okay, so we have planet. That's the big things. We have minor planet. These are these little small things going around the sun. And then we have dwarf planet, which is kind of like a giant minor planet, okay, but still not big enough to be a planet. And so this is kind of how we found all the things. And so there's again, you got to have a picture with an arrow pointing to something. That's Vesta right there. In a telescope, it looks just like a star, okay, and so just a little dot. Okay. Standard way that you find these things is you take two photographs and you look and see, that one of the objects moved. That process is called blinking. And these are two pictures right here taken 30 minutes apart. That's actually Pallas in that picture right there. Most of these asteroids are found in a belt surrounding the sun between Mars and Jupiter. Not all of them, but most of them. Remember that the asteroid belt probably formed when Jupiter moved inward and shut off the process of planet formation. So all these objects in here got caught orbiting around. If you add them all up, even though there's millions of them out there, they really don't add up to all that much. They actually add up to something less than our own moon. So they're really kind of small objects out here. And they're really far apart from each other, but they make sort of a donut shape. Toroid is fancy physics word for donut, sort of a donut shape surrounding the sun, because these orbits are not exactly in the plane of the solar system. They got kicked outwards a little bit as Jupiter moved in.